folks, how's it going? I slept so badly last night, so I am frazzled, but I have coffee, so hopefully we will get something working and implemented today. I'm hoping to implement std ranges 2 and some of the std ranges fold functions. So I think that's reasonable to get done in a couple of hours. We'll see how we go. I have Marshmallow currently sleeping at my feet, keeping me company, so that's going to be nice. Anyway. Okay, so here's where we ended up last week. Hey folks. We implemented Cartesian product and cycle. I hit a few hitches while I was on stream, but I managed to fix them in post. So those are now working. I even implemented advance for Cartesian product, which is an absolute pain. This thing here where you want to go an arbitrary amount forward in your Cartesian product view. You basically need to calculate an offset into each iterator, work out if you've cycled at all, and then set that iterator to new position, and then maybe recurse down to the next one. I have 2 comments there. But yeah, this function was a massive pain to write. But I think it works. So anyway, that's where we ended up last week. So now I want to do std ranges 2 and std ranges fold. So I'll start off with 2. So there is a paper. Yeah, I don't really know what you would use plus equals for with Cartesian product, but hey, it's possible. Ranges 2. Oh, that must be a 2021 paper. Ranges 2. No, did I just have 1 colon? It's a good start, good start. There we go. Ranges 2. Okay, so the idea behind ranges 2 is you want to be able to convert any range to a container. Some of the reasons you might want to do that is maybe you've built up a big pipeline of operations, and then you want to do some processing on them which requires that to be in memory. So say you produce a bunch of values through I don't know, doing a transform and doing something else and doing something else. You can't sort that, right? That's going to be generated on demand lazily. So in order to sort those values, you would need to put them in memory somewhere. So that's what ranges 2 is really, really useful for. Basically saying, take everything which this range or view is going to produce and stick it in memory. So that's what we're going to do here. So you can see some of the things they have here. So for example, you could take a std list and convert it to a std vector by calling std ranges 2. You could do a bunch of other things. It supports associative containers, so a map, convert that into a vector of pairs. That's kind of cool. Hey, thanks for the subscription, Random Forest. And then also the thing that I like is this pipe syntax. So you could take your list, you could take the first 42 and then stick that into a vector. Hey, thanks for the follow, RQ Stefan. So this is the kind of thing where I'm talking about where you're building up a pipeline of operations and then dumping it into memory. And this even supports nested ranges, which I think is new for... Yes, adds support for nested containers. This is new in this revision. That one scares me a little bit. I'm not sure if I'm going to get that implemented. Oh, can I explain the same as? Sure. So, same as here is a concept. And this syntax is constrained auto. So we have some concept and then auto. This says that the type of A is going to be whatever the type of this initializer is, so long as it's the same as std vector, basically. I'm not sure why they're using same as here. I guess it supports conversion. Or... oh no, it doesn't support conversion. That's the whole point. It's saying that this is... the type of this is exactly std vector, std pair. It's not something which is convertible to std vector, std pair. Yeah, it's a little bit weird syntax to get used to, but it can be useful sometimes. Okay, Hail Internet. Right. So fortunately, they've got like a bunch of design stuff, but then right at the bottom, they've got some wording for us. So this is what I'm going to steal. Okay, so it's implemented as a function template, and I will create a new header called 2.hpp. Whoops. I just hit enter. That's made some changes to my CMake list that I did not want to make. Okay. So we've got 2 if and TL ranges 2 HPP hash define copy paste. Okay. So now we're going to put this all in our TL namespace, and I'm going to have to go copy paste it again. In our actual client code, we wouldn't use, you wouldn't use the same as concept. It's just useful for showing what the types involved in this are. Okay. So I'm taking an input range, some C, which is an input range, some R, which is also an input range, and then any additional arguments which will be passed to the constructor of the template. Thanks to the follow echo 3 quick echo. Oh, am I intentionally streaming this with the game Cathy Rain? Oh dear, I did not update the stream. Let me go and do that right now. Can I do that from my phone? I think I can do that from my phone. Science and technology. Okay, that should have been updated. Thank you for that. People will be trying to go and watch some point-and-click adventure games and get me doing some ranges coding. Okay, so C and R are both going to be input ranges, and we have to specify that C is not a view. So this is actually a container, which is going to have something in memory. There's no container concept, but saying that it's not a view is good enough. And we're going to need to hash include ranges. Yes, coding does have interesting puzzles as well. Okay, so that's what our signature is going to look like. So here is saying we construct a container C with the elements of our range in the following manner. And now we have a bunch of cases. So if our container is constructible from our range and any additional arguments we want to pass in, then we're just going to straight up construct it like this. I'm going to copy paste this, and we're going to use if const expr here, because this means we don't need to do a bunch of additional overloads of std2 of TL2. We're just going to do most of our stuff inside here in if const expr block. So this says that if C is constructible from our range and our arguments, this is deduced at compile time, then we're going to return constructing our C just by forwarding in R and our arguments. Okay. Any questions about that, feel free to just drop them in chat. Otherwise, okay, so this is asking if it's constructible from C and this from range T. So my understanding is this is something which is in a different paper from range, stood from range, will be explored in a separate paper by Tristan Brindle. So I'm not going to do this. I'm just going to ignore that for now. So otherwise, if C is constructible from args and indirectly copyable... Okay, right. I'm going to read this out and then I'm going to explain it. So if C is constructible from args and the range iterator for R is indirectly copyable from the range iterator of C, what that means is we can construct C with the R additional arguments, and then we can copy our the contents of range into C. Indirectly copyable just means we can copy it by dereferencing, essentially. And you can see that's what it's doing here. It's constructing C with args, and then it's doing ranges copy. So one thing I think we could do here as well is, like, this is constructing our C, and then it's doing a copy. But some containers will be able to call reserve on them to reserve the memory. So I think that's an optimization we can do. So I'll go and copy this for now. If constexpr, oops. Here to get confused by coding. You're very, very welcome. Also, if constexpr, okay, so if it's constructible, C is constructible from args and range iterator T is indirectly copied. Is that the right way around? Indirectly copyable, because I would have thought you would be copying from R into C, but maybe I'm wrong. Stood indirectly copyable. Let's have a look. Okay, so it is from to. All right. So that is correct. Yeah, this kind of C++ is probably quite far away from any Java you've seen. This is like the nitty gritty, like generic programming C++, where we're doing a bunch of kind of weird things depending on the compile time characteristics of other types. Okay, so if this is all true, wonder what the formatter thinks of this. If I hit Control KD, the Clang format just says, "I don't know what you're doing, buddy. You just do you." Okay, we are constructing our C. We are copying from R into C. Okay, so this is the unoptimized version. I think we can do better than that in some cases. So if maybe we can do that inside here. We can potentially pre-allocate this memory. In here. Although stood inserter, is that going to push back? Yeah, that should be fine. Okay, so if constexpr, so if we can call reserve on our container, and if we can get the size of R. So in order to ask that, we need to say stood ranges sized range, which will tell us if we can get the size from our input range, and if we can call reserve on C. So I could just write a requires clause in here. I'm going to make a concept for this. So I'll create a detail namespace so that no one else uses this. For some container, concept, what concept do I need here? For something to be a container, I guess input range. for some input range C, something is reservable if given some C, we can call C dot reserve with, I guess that's the size type. Let me go and check that. Instant vector reserve is size type. Okay, and there's presumably a std size type t in ranges. Range size t. Std ranges range size t. Okay. So I can call c.reserve with std decal val std range is range size t of c. Okay, so what I'm saying here is something is reservable so long as given some c, I can call the function reserve c.reserve with some instance of its size type. And I think, will that do? Do I have to specify the return type of this? I feel like this might even be mentioned in this paper. Reserve and assignable. Okay, so this is kind of broadly similar to what I did. Yeah, range size t. Yeah, this will do. This will do. Okay, so this says if something is reservable. So if something, if R is assigned for range, a sized range, and detail reservable C, then before I call this copy, I can call c.reserve std ranges size of R. So this will get the size of our range we're converting and reserve that amount of memory in our new container. Yeah, it probably would be more readable. We can do std ranges range size t c s. This just stops me having to do the whole decal val nonsense. Okay, this says exactly the same thing I was just saying, it just says it a little bit easier. Thanks for that. Okay, I think that should work. At least worth a try. Okay, what else have we got? All right, so this is the case where we have a range of ranges and we want to change the container type, like here. If we have a list of forward lists, we could change it into a vector of vectors, like so. I guess we can implement it. So it says that the value type of C is an input range, i.e. if you get an element of the container C, then that's an input range. So it's asking if this is a container of containers. Or a range of ranges, rather. And then the same for R. And then it's saying that the value type of the container is not a view, i.e. it's a container. And you can copy the value type of R to C. Okay, that all makes sense to me. Thanks to follow even to odds. Go ahead and copy paste this. I'm going to comment these as well. So this is our just construct from range. this is our construct and copy, potentially reserving memory. And then this is our nested case. So else if const expr and then bunch o stuff. Okay. So std range is input range. The value type of C is an input range. And I could make this into concept as well, just so that it's a bit clearer to read. And the value type of R, is an input range. And the value type of C is a container, i.e. it's not a view. And you can copy the iterator of R's value type into the iterator of C's value type. Okay. So this is, again, a check which is going to run at compile time, and I'm going to give this a name. I'm going to call this is nested container. That's not quite right, because this is saying that C is a nested container and we can copy. Can anyone think of a good name for this? Call it like, is nested convertible to, I don't know. If someone comes up with a good name for this, then we can factor it out. For now, this will do. Okay, and that's equivalent to this nonsense. So we're constructing our C from the additional arguments that we got. Then we are piping our range into transform. I guess this is std views transform. Std views transform will call this function on every element of R. So for every element of R, it's going to convert, because R is a range of ranges, then for every internal range, we're going to convert that range into our new one. That makes sense. And then we're going to copy from our view into our container. Okay. I think that makes sense. Don't we need a std forward on line 40? No, because R is not an R value, so it's not going to make a difference. The auto ref there is just mostly because we don't really care. Auto ref can mean forwarding reference. It can also mean I don't care. Okay. Yep. This code is so badly formatted. Oh my god. Like I'm hitting KD here to run Clang format, and it's saying nope. Just nope. Okay. Yeah, I would really like to get a good name for this. Please do give me your suggestions. Anyway, I think that's, otherwise it's ill-formed, so we want an else case. So one way to do this is we want to give a compiler error if none of these are true, right? So the way you might think of doing this is saying static assert false, just to say always give an error and say C is not constructible from R. This is actually ill-formed by the C++ specification. For the basic idea is that if a given instantiation of a template, which if const expr kind of is, is always invalid, then the code is bad. It's ill-formed. So the usual way to do this here is have some always false, detail always false, and make this dependent on some template parameter, and stick this up here. And just say template class that we don't actually care about is a const expr inline bool always false equals false. And this is enough to get around the language rules. Yeah, someone has proposed always false before. I can't remember how it happened. I believe the static assert will not work like this. In my experience, this works because always false is dependent on C. So that's enough to get around the all template instantiations are invalid rule. Matryoshkable. I love that. Okay, yeah, I'm going for that. Matryoshkable C to R. That's fantastic. Okay, so we're taking two input ranges, C and R, and we have a concept, Matryoshkable, which is all of this nonsense. Okay. Stood Matryoshkable when detail. Okay. And I'll give a comment to say what this really means. To say that C is a nested range that, or rather R is a nested range that can be converted to the nested container C. Okay. That cleans up that code quite a lot. Nice. Okay, so that's our first overload of 2 done, I think. Now the next one is the case where you pass it a container template as the first template parameter. So you can see up at the top here, you can pass like std vector int to say I want to convert this to a vector of ints, but you could also just say convert it to std vector. I don't care about what this type is as long as you work it out and as long as it's a vector. So this overload is now to support that. And it's using ctad, which is constructor template argument deduction. Okay. So I'm going to copy this. It's going to be broadly similar. Okay, so it takes some, not a container type, but a container template, some input range. Wait, this is std range is input range. Yes. Forgot that a few places. Should really done search and replace, but well. And std ranges view as well. Okay. So yeah, we're taking some template C, input range, and any other arguments, and we're going to convert to some container type. Okay. So this is equivalent to ranges 2 of the container type, and now we just need to work out what the container type is. Okay. So I'm going to say that the Cartesian product did get finished. Class container type equals, and we're going to write some metaprogramming stuff to figure that out. Detail ctad container. That reasonable? Ctad container. And then give it cr and args. Okay, so basically once I've written this detail ctad container thing, then that will work out what our container type is, and then this will work. Okay, so detail ctad container. We're taking all of this nonsense. Let's make this the same. And we are deducing our ctad container. Right. So container type is determined using ctad as follows. Let iter be a type meeting the requirements of input iterator such that... Okay, so what does this mean? This has got a lot of code. I want to know what it means first. The iterator category is input iterator. The value type's the same as that. Okay, so basically it's an iterator which is the same as... essentially the same as the iterator for R, but is an input iterator. So it's basically being like a lowest common denominator iterator for this type. Okay, I guess we can write a type which does that. Detail struct. It's going to take some input range R, and we'll call it input or fake input iterator. So the take claim using the iterator. No, I'm gonna copy all this. And get rid of these. Okay, so using, get rid of this, iterator category, oops. Oops. How do I type? Has my keyboard layout changed? Yes. I use Dvorak, so sometimes if it changes to QWERTY, I get very, very confused. Oh, there's obviously some kind of keyboard shortcut that I'm pressing, which is doing this. What on earth is that? Go away. Okay. Right. So this is just, I'm just cheating a little bit and copying all this. I do find, I switched to Dvorak like, I don't know, 10 years ago or something, because I got bad RSI. It did help. Okay, so I've got an iterator category, which is input iterator. My value type is the same as that of R. Difference type, same as that of R. Pointer is a pointer to the value type and references that. Okay, cool. To qualify as an input iterator, I need a few other things, I guess. No, std input iterator tag. The intuition for writing this is, I'm not entirely sure, but I'm guessing that it's so we want to be able to get the type of constructing a container from these two iterators, and we want to use input iterators to do the deduction. I'm sure there's probably some case where it matters. I can't think of what it is off the top of my head, but this was written by, I think, Casey and Eric and Corentin, who know way more about ranges than I do, so I'm going to assume that they know what they're talking about. Maybe I'll ask them. Yeah, we can hit Corentin up on Twitter or something and ask. But input iterators require equality, dereference, plus. And I don't actually have to implement these, but fake input iterator reference, or no, I want reference operator star. I want fake input iterator reference operator plus. Fake input iterator operator plus. Int. Ladder. Fake input iterator constructor default. Equality. Friend bool operator equals fake input iterator A and fake input iterator B. Alright, that should do. Okay, so that implements this logic. This is our iter type. Okay, so container is decal type of C of all this, if that's a valid expression. So I guess I can do this with some inline requires clauses. I'll make this a struct. In fact, I can make this a function. And say that if const expr, okay, so if this is valid, which is requires given some C and given some, oh no, we don't need some C, given some R and given some args, then we can write C of our args. I don't think this is quite right. So is it? No, maybe this is right. Yeah, because R could be a reference, and so could args. Oh, I think I need stood forward decal type R. Yes, that looks better. I mean, not better, but more correct. Okay. So if that's valid, then that's going to be the type we return. I could just write R, yeah. Yeah, true. The use case for this is we're trying to work out essentially what these types are, and only use them if they are valid. Yeah, too much habit from Lambdas. Can I write a helper for this? because like I'm gonna need this type again. I'd say type if valid, like anyway, for now, if that's valid, then we're gonna return that type. I'm just gonna be repeating myself a bunch here, aren't I? I can't remember what the easiest way to do this is. Like, so I want it to be the decal type of this if it's a valid expression. So you can't just have a like a using expression or something like that, because it would if this is invalid, then it would fail. There must be a way to do this with concepts, right? Like I've done this in the past with horrible sphenatrix and things like that, but there must be a newer way to do this. Does anyone know off the top of their head? Because like I can go ahead and copy paste this, because you could say, like, given a bunch of template nonsense, base concepts, what do you mean? And should I work out what the easiest way to write this? Just requires, yeah, like I can write the requires expression, right? But that just tells me if this is valid or not. I then also want to get the type out. So like I can copy paste this and say that this is valid, and then if const expr that, then return exactly the same thing. You know, that's what I'm saying about the I'm just repeating this. I'm checking if it's valid and then I'm returning it. I'm trying to remember if there's a way to do this without the duplication. I can use the macro. Alright, let's just duplicate it for now. It's only like 3 expressions. But yeah, there must be... Oh, in fact, I'm not even using this one. Otherwise, else if const expr requires given r and args okay, and this should be forward r dot here. Okay. And then in this case, yeah, you can use requires clauses basically anywhere that you need a const expr bool. It's pretty cool. So instead of iter here, I want my fake input iterator for r. Yes. Just go ahead and alias it. Okay, so in fact, I can put this up here. Hey, thanks to the follow, Shivix. Okay, given 2 iterators and stood forward args of args dot dot dot. Don't even need this. Okay. So this is saying that I can construct my container from 2 fake input iterators of the correct type and the argument. Hey, thanks for the subscription, Lambda Knight. I need to return in here. Okay. Otherwise it's ill-formed, so I can do the whole static assert thing again. Just copy paste it. Okay. That's some janky code. Oh, it's not even correct either, because this is our requires expression. I still need to duplicate this here. And this will be yeah, returning C constructed with decal val of, oh, this is where I can use my using iter equals fake input iterator for R. Decal val of iter decal val of iter and decal val of args. Returning decal val, the decal type. Yes, so I'm not actually going to be calling this function at runtime. I'm only ever using it to get its type. Yes. Oh, you're right. Like returning decal type. Yes, yes. I need a decal val here. Decal val basically says, imagine I have something of this type. Or in fact, I don't even need that, do I? I just can do that. Yes. Okay. I don't know if this will work, but we'll give it a shot. Yeah, I could use type identity for these things. I feel like, am I missing some braces? There we go. Okay. So we got our container type by getting the decal type of this. Okay, this is some really, really horrible code. I haven't even tried to compile this yet. I have no idea if it will work. Okay, and then there's the adapters, which will allow you to do the piping. Let's see if this compiles first and get this working. Then we can move on to that. All right, let's write some tests. Don't make those changes. Okay. Include catch2, using catch for tests again, tl slash, not getting my completion. Hey Biddle. Yeah, it could make a type alias. I'm only using it once, so it doesn't make a huge difference, but yeah, you're right. Let's make test case from the paper and just steal all of these. Actually, it'll take a bit of editing to get these to compile. You know what? Let's just write it wrong. Okay, so let's write test cases for all of our branches. It's always a decent way to go. So constructing from a range, such as, can you construct a vector from a std list just by default from the constructor? I don't think you can. Can you? Did they add constructors for that? Iterators, but no. Yeah, not seeing anything like that. Oh, could do a vector to the vector of the same type. I'm not sure what types will actually call this constructor. Like this would work for the copy constructor. Like if I just copy a std vector to a std vector, then that should get called. So I'll just have a std vector of ints, and I will say that b is TL to, oops, not getting IntelliSense. Maybe I just have to regenerate CMake and they'll get it. TL2 std vector of int, and then I'll also want to test just giving it std vector and letting it deduce the type. So I can require that, can I just say A equals B? I don't think I can. I have to use std ranges, compare, operator equals equals. Oh, okay. So I can just say A equals B, and then call this C, and require that A equals C. Hey, thanks to follow Sipwingen. Okay, let's compile this code for the first time. That's how it works, right? You write code for an hour and then you try and compile it and it all breaks. I think it's not that they deprecated the other comparison operators, it's that the spaceship operator, the other ones can be defined in terms of the spaceship operator. So 2 doesn't stand for anything, it's just like a A2 vector, convert to, essentially. Come on, rechecking. There we go. All of our compiler errors. Very nice. Okay, so that's obviously I've written the type wrong. Should be ranges. Okay. Just go and rebuild because that will have a bunch of cascading errors. Yeah, coding and streaming at the same time can be difficult. It's like last time when I was writing the cycle implementation and just had a complete brain blank on how to implement the maths for it. That can happen. Okay. Shall not have associated constraints. I just want class here. And then say, whoops, std input range C. Might be right. Let's see how this goes. Okay. Semicolon. I still love that name. So good. Why do I prefer class over type name? It's shorter to write. That's literally it. Oh, goddamn. Similar for this one. Okay. Input range C, and std ranges input range R. I guess I could put that here as well, instead of sticking the requires clause. I could say it's not a view as well. Come on, come on. And is just this constraint has to be true, and this constraint has to be true, and this requires clause has to be true. What am I missing here? Have I got too many closing braces? Yes. No? Indirectly copyable. This looks fine to me. Anyone see what I'm missing? Saying that this is an input range, that's an input range, that's not a view. This thing is indirectly copyable. Is it range is indirectly copyable? It is still indirectly copyable. I don't see what I'm doing wrong here. Yeah, it should take two parameters, in and out. It's an iterator that I just need. Is that it? Yeah, it's a concept, so I don't need underscore v. Like, looking at the compiler error, it seems like I missed some braces or something, but that's very strange. Missing previous one? Not that I can see, like... Oh, this is std input iterator tag, and std ranges range value t. Oops. Yeah, I have no idea what's up with that concept. Maybe missing something up here? Like... It's definitely some weird syntax thing going on right now. Definitely had too many of those. Why should we use concepts when svna already works? One, svna is horrible. It's the absolute worst. Two, in theory, better compiler errors. MSVC's compiler errors leave a lot to be desired right now. We're working on it, but GCC's compiler error is fantastic for concepts. Like, really, really good. It helps you narrow down your compiler errors a lot. Three, in theory, better compile times. I'm not sure what the measurements there are, but in theory you can get better compile times using concepts. Range iterator to use a dependent template name must be prefixed. That doesn't seem right. I'm saying that C is constructible. Yeah, that's definitely wrong. That's I'm going to compile this with GCC and see what errors it gives. Why in theory the compile time's less, the compiler has a lot more control over the concepts rather. SVN was like, people worked out that, oh hey, we can abuse this thing which wasn't designed for this in order to remove things from overload sets. Concepts is actually designed for it. CMake generation. I missed a stid before ranges. Yeah, you're right, thanks. Oh, weird. What's going on there? Or delete the cache, rebuild. Same line again. Oh, yeah, you're right. Sorry, thanks. Wow, that's building. Okay, got GCC 10, so we should get our good compiler errors. I'm glad we did make this its own concept rather than trying to debug all of this inside an if const expr condition. That would have been a nightmare. Generating done. Okay, GCC, give me some better errors, please. What on earth is going on here? Ugh. I have no idea. Seemed like something went wrong with the CMake integration. Okay, you know what? This whole concept right now, that's true. See where we get now. Yeah, if const expr makes things so much cleaner as well. I mean, like, unless you write code like this. Although it would be worse with this, Vine. Okay, so constructible from and indirectly copyable unexpected token. Indirectly copyable, sorry, is missing close brace where like that looks right to me. Switch const expr. What, an extra one here, really? That looks like. Yeah, I think this looks fine. I don't know what's going on here. Yeah, switch const expr. I can't remember if there is a paper suggested for it. Syntax error requires. There's something so weird going on here. Gonna delete the cache again. Could not load cache. Alright, I'm gonna restart Visual Studio. Catastrophic failure. Yeah. Sounds about right. Okay, make sure I get the right one. Got so many different installations of Visual Studio in here. Let's try that again, shall we? While it's all loading up. So the next thing, once we get this working, is getting the pipe working. So my understanding of that is, so we'd want to essentially capture args inside a tuple and then have some bar operator overloaded which forwards those all of those arguments from the tuple into our already existing implementation. I think that should be enough. Come on, come on. Did I say to open ranges? Here we go. Come on, Visual Studio, what are you up to today? Wondering if this is to do with, I think I accidentally set my my streaming settings in OBS higher because I was doing some demo recording earlier. I don't know if that is making my machine just run a lot slower. Jeez, oh. Oh, there we go, finally. Still getting a catastrophic failure. Okay, let's try rebuild this and see how we go. Okay, CMake generating. I'm done with my coffee now anyway. Okay, so let's have a look at this metroscopal again, because like someone is getting very confused. We're missing something like right up the top here. Reservable looks fine. Always false looks fine. Makes no sense to me. Hey, thanks to the follow, Adacon. Uncomment the properties one at a time, yeah. Okay, generating done. Let's see how we go this time. Thanks the follow or seal. Like saying crushable to true shouldn't make too much of a difference right now because it's the last if const expert here, so these two should still get picked before this one, so we shouldn't get any additional compiler errors. Okay, here we go. Alright, we're still getting an unexpected token. Line 69, nice, although not nice. Gonna remove this and see if we still get an error. On line 70, oh yeah, you're right. Okay. Syntax error in requires. Do I need requires here? No, requires is for constraining like a function or something. Oh no, why is it giving me like you can put requires clauses inside if const expert. And then another error on line 43. I guess C should be visible because it's there. I'm not seeing my mistake. No, for now, let's class R. No, we don't need class there. And get rid of this for now. And get rid of this overload so we can focus on the original overload first and get that working, and then we can do the next one. So this should be enough for the test which we wrote. Oh no, it won't be actually. We'll get a... Do you need additional brackets around the expression inside requires? Maybe. Okay, no matching overload found. That's okay because I just removed that. So that's actually correct. Okay, but it seemed like the first one at least compiled. So... yeah, requires statement. This will not give me the right thing, will it? Yeah, do I need extra braces around the internal thing? Yeah, maybe I do. Requires expressions. No, like this is just saying that this will compile. I mean, I can give it a try. Do I need a... Oh, right. So the difference between this and this is that this is checking that this is an expression which is valid, whereas this is checking if this is a statement which is valid. So it'd have to have a name here. So yes, I do need these braces. And then I'll need the same here. So it's saying expected semicolon. Oh, I need semicolon though. Okay, so that kind of worked. Still getting no matching overload found, but we're making progress. Invalid template argument for C. Oh, because I commented out this one. Come on, come on, come on. Just getting an error. Didn't get the error before because I wasn't instantiating the template. Now that we're instantiating it here, we're getting the error again. Missing a semicolon before the opening brace on this line, like... Well, let's give this a go. Just straight up return this, because that will work for the case that we currently have implemented, and then go from there. Because this will call a copy constructor. Template is a template parameter. The template parameter is itself a template. Two is not member of TL. But it's here. Did I close my detail namespace? Oh, no, I didn't. that again. Oh, miracle. Okay. Alright, so there's some issue here. Let's go bit by bit. Is this still gonna fail? If so, I kind of want a better way of doing this anyway. Do I need a semicolon inside the braces? No, because this is I'm checking an expression, not a statement here. The second pair. I did want a better way of doing this anyway, but I'm not sure what the better way is. Let's just make this a concept. Which takes some class R, some args, except construct container from. Try this. See if that works better. Semicolon. C cannot have the type container type. The container type is void. Okay, that means it's saying that this concept failed. I don't think that should fail. CR args ctat container. Just try R and args here. So there was obviously a weird thing of not being able to use requires inside that if context were. Construct container from R and args. So if I switch this to true, so it's going to compile. Am I missing something about requires expressions? Yeah, maybe I don't want those braces there after all. Yeah, so that succeeded. Oh, this will definitely not compile. Let's try that again. Try with the variable name. Yeah, okay, something is going very strange, and oh wait, we don't have a C here. Could have done with a much better compiler error there. Oh, C is a template, right. Okay, this looks like it's working. Okay, so for some reason, we can have that as a concept, but having it as a requires clause inside if const expert doesn't compile feels like a compiler bug, maybe. Yeah. Okay, so we'll have to make all of these concepts. Okay, and then this one. Need template class. All same stuff. We'll call this one construct container from iterators. Take some args, iterator, and oops, tests this. And then in here, we say construct, oops, container from iterators CR args. Let's try this. Semicolon again. Oh. Yeah, I know. Okay, looking promising. It worked. Cool. So we had tests for this one and this one. So now we want tests for construct and copy, such as converting list to vector. like so. Have a std list. And convert that to a vector, and then require this std ranges equal and give it A and B. A and C. Okay, so now we're testing converting a list to a vector. We should test this one and this one. Succeeded building. We should really actually run our tests. And then we can try a nested one. No idea if the nested one will work. Come on. Yeah, you can make sure it gives the right type as well. Yay. Okay. Nested. What was the one in the paper? Converting a list of forward lists to a vector of vectors and a vector of decks. Yeah, let's try both of those. Forward list. And deck. And we want to ensure that these are equal. Oops. Require that that we need to make this nested for inner in vec1 auto ref. Require that we need to leap over both of these, and one's a list. This is where I would really like a zip range and zip them together and compare them, but we don't have zip right now. List it equals begin. Require that std ranges equal inner and listed. I think that's right. Do the same for vec2. Parentheses issue? Yes, thank you. Give that a try. I have no idea if this will compile. And if this works, we can do the piping version. There we go. Okay, so in line 80, when we try and copy, this looks like it's hitting the wrong. Is this hitting the wrong one? No. So we're trying to copy. Yeah, this is hitting the wrong one. Oh, and we didn't fix our matryoshkable yet. But that shouldn't matter here, right? Like... Oh, it's because we had to get rid of this thing. So it's not checking that constraint. Now, what could the issue be here? Is std ranges range iterator t, isn't it? Oh, it's just iterator t. Bad compiler error. So now the outer container should hit this case, and the inner containers should hit this case. Okay. Argument list missing. Oh, std ranges range value t. Okay. Oh, we need to return C at the end. But other than that, it seemed to compile. Whether it does the right thing or not is another case. Anyway, while it's compiling, you can think about the final version, which is this one here. So in addition to the function described above, also defines a closure object. Accepts a viewable range and returns a container. So that would look like const expert auto 2, and that would just take any arguments. Now, do we have to specify that any of these arguments are not an input range? No, because this one will get selected if it's a better match, so I don't think we have to. Okay, and then we're going to need some type to return. So let's call it, in fact, we don't need a name for it really. And it's going to store a std tuple of args. Actually, we do need a name for it. Call it closure. Just gonna store some args and could give it a constructor, but anyway, we'll leave it like that for now. Okay, so when you pipe something into it, then it's gonna have a friend function. Template. Is that right? No, it'll be a template and then friend. So it's gonna be a template which takes some input range on the right hand side. Friend auto const expr. Const expr. The pipe operator. Oops. So it's going to take some input range on the right hand side and then closure. This const. Or maybe this has to be an R value. Yeah, I think this should be an R value. And then closure. And then we're going to call TL2 with the range and container and our arguments. Okay, so we're going to need a couple of overloads to this to mirror these, I think. Return std apply of using std apply to grab the arguments from our tuple and return TL2 of our container and std forward our range and forward our inner arguments. Okay. And give that args underscore. Okay, so this will apply this function to call TL2 with the range and the inner arguments which we captured. I guess, yeah, we can std move these. Okay, so that's one overload, and then the second overload is much the same, but this is just going to be an input range. And also not a view. Std ranges view C. C dot, yes, thank you. Is this the same otherwise? I think so. Okay. So that defines our closure, and then we can have a forwarding template. Which is our constructor. And that just constructs args. Oops. Okay. So then in here we return closure forward in our arguments. All right, how is that? Will that work? It seems reasonable. Oops. Why don't we give it a try? So for our test, we can write a test case for piping. And we want to do something like have a vector, and then instead of doing TL2 vector of A, we pipe it like so. And then just like the other case, we want to also test for this version. Okay, so the idea is now when we call TL2, that version, it's going to return some closure type which captures our arguments and then forwards them when we use the pipe operator. So let's see what compiler errors we get, because this will almost certainly not work first time. Okay. Template declarations are permitted only. Okay, yeah, I'm gonna have to take this out of here and put it in my detail namespace, which means I need to make this a template. Hey, thanks for joining, Biddle. Okay. I think the constructor template argument deduction should kick in here without me having to do anything. Might be wrong. Okay. Unexpected token template. Oh, did I paste this in the wrong place? Here we go. Error on, yeah. Okay, what's wrong here? Just need to make this variadic. What am I doing wrong here? Anyone seeing what I'm doing wrong there? Should be variadic lambda returning TL2, not capturing R. Yeah, that would do it. I mean, it doesn't explain the compiler error, but it explains why there would be a compiler error. Still unexpected token ... Just remove these for now because our test case is not using them. Then see if we get a different compiler error. No, shouldn't need a comma there. 2 is not a member of TL. Oh, right. Gonna have to cut and paste this and put it below all of these ones. And do detail closure here. Hey Marshmallow, do you want to come say hi? Hello everyone. Here's Marshmallow. He is very soft. He's just like... He's a teddy. Aren't you? You're just a teddy. Okay, you go back, have your nap. Have fun. Okay, what errors did we get here? Function does not take 0 arguments. Well... This should allow 0 arguments, should allow an empty parameter pack ... in the wrong place. Yes. Okay. Is this because CTAD's not kicking in? Still. Oh, because I'm... Right, yeah. I still need to be able to pass my template parameter in. Oh, I need to think a bit more about this. So, yeah, I need to be able to pass this, and then I should capture that in my closure type. And then we need another version where this is a input range. And I capture that in my closure type again. That's not going to quite work because closure can't have arguments like it can't take either a template or a type there. I guess I need some way of wrapping this C so I can pass it into closure. So closure, it currently just has arguments, but I guess I could just make 2 types. Like, that's not too bad. we can just make one type which takes input range called C, called it closure range, and uses this version, and then a different one called closure CTAD, I guess, which has a template parameter. These are the same implementations, right? So it doesn't matter which one I keep. So in this version, I use closure CTAD, and in this version, I use closure range. See how that goes. No type specifier. Need to make sure I use the right names in the constructors. Identifier closure up and here. Oh. Hey. Has this worked? Incredible. All right. Bang on 4 o'clock for me as well. So yeah, that seemed to work. Ideally, I'd also test for passing in additional arguments here, but I need to head off. But yeah, we implemented ranges 2. We had some horrible code. We didn't fix this, but I can look into that later. Yeah, I really want a nicer way of doing this. I don't like this essentially just saying the same thing twice here. That's not great. So yeah, the code is awful, but it works. 2 hours to get that going. But hey, this is a really useful utility. Like, it's used so many places when you're doing ranges code. But yeah, I'm gonna at some point probably clean this up and push it up to GitHub. Didn't get to fold this time, maybe next time. As always, if there's other things you'd like me to try and implement, just let me know. I'm always open to suggestions, even if it's not some ranges stuff. Can do anything. If it's in C++, then it goes. So thanks for joining, everyone, and I will see you next week.